Hello class, this video is on how to do a MANOVA using the statistical software Jamovi. I'm going to walk you through how to set it up and why and what to do. So the first thing we need to do is go into data, and it's blank right now, so we just need to go to open. I already have it saved, so I'm going to click on MANOVA, and you'll see that we have three DVs, I, shared, social, and one condition. This is our ID variable here. And then I've actually done a thing where I've calculated the Mahalanobis distance and whether those are significant differences or not. And we'll get to that here in a second. But just remember, this is a research scenario that a researcher is looking at studying the effects of behavioral treatments to increase desired behaviors of children who have been diagnosed with Asperger's syndrome or on the spectrum. The researcher develops a couple different interventions. So she's looking at positive versus negative reinforcement interventions. And she has about 55 elementary age children. And she has them for about 6 weeks. And she's actually administers, after the 6 weeks, these three different measures of social skills behaviors. Right? So we have I, shared, and social. If we click on I, we have the amount of eye contact. You see that here. Click on shared, we have amount of spontaneous shared enjoyment and amount of social reciprocity. And so remember, in a MANOVA, the only reason you would do a MANOVA is because you think that the three different variables are related. And they're related in a theoretical way, and you want to run basically a MANOVA using a combined DV of these three DVs. And you do this for a number of reasons. It really allows you to look at that IV, the independent variable of positive versus negative reinforcement, on multiple DVs. Remember, it allows you to reduce your type 1 error and alpha slippage because you're only doing it a couple times. So we're going to kind of jump into it really quick. And we are going to look at the different variables. And so the first thing we need to do is we need to look at our data assumptions. So assuming we have normality of each of the individual data points, missing data, all that kind of stuff. One of the first things we need to do is we need to assess whether there's linearity, right? Whether there's a linear relationship among these three dependent variables. So to do that, we go analyze, right? And we want to look at correlations. So we go regression. We want to look at correlation matrix, and we just take these three and move them here. And it tells us that right here in this box here, that I is, oops, sorry, I had the wrong variable. Let's try that again. There we go. So I is correlated to social significantly at 0.644. I is correlated to social at 0.406, and social is correlated to shared, right? So we know that they are all linear related. There's another thing that we need to test, and that's using Bartlett's test of sphericity. Unfortunately, in Jamovi, it will not run that analysis without learning code. So we're not going to do that just yet, but we need to go back to our data. And I noticed something. I don't know if you picked that up, but if we double click on here, we want to make sure that that's continuous, not nominal. We want to make sure that's continuous, not nominal. And then the social variable is continuous, not nominal, right? And it's okay if our condition is is nominal, right? All right, so now we do have a linear relationship. We can't test for Bartlett's. So really the next one we're going to look at is homoscedasticity. And you can do that when you actually run the MANOVA. So let's do that. So we analyze, and we hit ANOVA, and we hit MANCOVA. It doesn't say MANOVA in Jamovi, but it says MANCOVA. So we click on that. We move our condition to our factors because that's positive versus negative. And then we put all I, shared, and social into our dependent variables. Okay. So we have all these clicked, and we talked about those in class. And when you use Poli's trace or Wilkes lambda or Hoteling's trace or Roy's largest root, but we also want to check our assumptions. So we click on box plots, Shapiro, and QQ plots. So let's first talk about the box plot. And we're going to move this over so we can see it a little bit. So here's box homogeneity of covariances. So this looks across the it's really homoscedasticity, right? So you're looking at how the covariance of all the DVs are equal or not equal across the independent variables. So you want it to be greater than 0.001, which it is right here. It says 0.413. You do not want it to be significant. So basically we can say we have homoscedasticity. Well, another thing we need to really look at is sphericity, right? And so this helps us get into that idea of different how they are related to each other, right? And if we look at that, we look at the QQ plot, and does that look normal? No, it doesn't. So we have an issue, meaning that the normality across the dependent variables is not similar. This axis is your Mahalanobis distance, and we talked about that in class and how that's the essentially the residual from the regression line and the distance from here to here. And the reason we don't have this sphericity is you'll see this is really far from here, this is really far from here, really far from here, and so forth. So what I did is I actually set up the data set. So I calculated the Mahalanobis distance, and I calculated the probability of those being significant distances or not. So if we go back to data, that's what these two variables are. Right here, I'll double click on that. So that's the Mahalanobis distance, and this is the p-value for that, so the significant. So we haven't talked about this in Jamovi, but there's a way to filter those like you do in SPSS, and it's actually quite easy. You click on filter. You're going to go into this FX, right? And if you click on that, there's all kinds of things that you can click on. But really what I want you to do is click on the Mahalanobis p-value, double click it. And then you're going to say is greater than 0.05. So essentially, we don't want any of the significant ones in the data set. And just hit enter. And look what it did right here and right here. It actually is excluding those from the analysis. So if we see up here in our original analysis, right, we have 49, 3 and 49. So let's see if that's the same now that we go analyze, MANOVA, MANOVA. We're going to put condition into factors. We're going to select all three of these variables as our DVs. Click on that, and click on that, right? So again, we have homoscedasticity, we have normality, multivariate normality. Notice that we changed a little bit in our DVs. It's only including the one, and it didn't fix it. It got a little better. If you see here, it's a little better, but not that much. And that's okay. You did what you could do. You removed the multivariate outliers. If we go back to here, we see that those aren't included in the analysis. And if you actually look here, you can see that those two, that one's 0.035, so that's less than 0.05, and then that one is also excluded. And scroll down if you just want to check to see, but I don't believe that there's anything that is significantly a significant multivariate outlier. So if we go back to analysis, really what you're going to report for your analysis is using this last analysis with those two cases excluded. So you're going to report Box's homogeneity or homoscedasticity of covariance matrix. You're going to report Shapiro's Wilk. You could include your QQ plot if you'd like, but then there's one question where we haven't talked about, which is which of in the multivariate ANOVA table, the MANOVA table, which one of these lines do I read? So if we think about it, right, we have 50-something participants, I think 55, and we go back to the lesson, which one do we use? Well, we have homogeneity of variance, we have homoscedasticity, we're kind of good there, right? And so we can either do Wilkes lambda, that's if all your assumptions are met, We can do Hotelling's Lolly Trace, and that's only you use that when you have an IV with 2 levels, which we do, right? So we have positive versus negative. Or we can use Pillai's Bartlett Trace, and you use that when you have a violation of homogeneity of variance or small sample size. And you could argue that we have small sample size, but I think for this analysis, reading the ANOVA line of Hotelling's Trace is probably going to be your best bet because you have 1 IV with only 2 levels. All right, well, if you have any questions, like always, just email, call, text, or we'll get on Zoom and try to figure things out. Hope you have a great day.